sadhakas, we are at a blissful moment. We are entering a phase when we are going to demonstrate the potentialities of Vedic mathematics and the way Vedic mathematics can help the modern mind to dissolve its mental blocks. As we know, Vedic mathematics is the mathematics of a spatial order. However, the modern logic of linear order has resulted into mathematical problems and mathematical knots. We know that Christian Goldbach, German mathematician, had given conjecture in 1742 as that every even number greater than 2 can be written as sum of a pair of primes. This problem is yet a problem for the modern mind. Modern mathematics is keeping it in the list of mathematical problems. That way it is one of the oldest mathematical problems of modern mathematics. Despite many efforts, serious efforts, continuous efforts by individuals, by institutions, by group of mathematicians, the conjecture is remaining as a conjecture. Now, today, we are entering upon the proof reached at by applying the Vedic mathematical tools. Vedic mathematics is a spatial order mathematics. It means two space in the role of a dimension. We will be coming to these aspects afterwards, but initially we are exposing ourselves to the statement of the conjecture. Once it will be taken as standing proved, so it will become a Goldbach theorem. Formally, the proof of Goldbach theorem reached at by me begins with its a statement. Statement is that every even number greater than 2 can be written as a sum of a pair of primes. This proof is availing very simple properties of whole numbers, positive whole numbers, counting numbers only, and the principles being applied are of Ganita Sutra 1, one more than previous one, Ekadikein Purve, and Ganita Sutra 1, Anurupain, proportionality. So this linear sequence and the symmetry rule together are the basic principles which are at the base of this reach. It is being reached at in terms of 4 steps, step 1, step 2, step 2A, and step 3. Today, I'm only remaining at step 1, and it is that let even E be expressed as M plus M, means E even is accepting its organization as a pair of halves. So to proceed for this proof, First of all, let us see the unique way in which we are reorganizing the number E as m plus m. And then we are constructing the set D1. This set, in fact, is a set of duplexes. The organization is of a pair of layers. The upper layer has 0, 1, 2m, and the lower layer has 2m, 2m minus 1, 2m minus 2, and m. Now, this way we are making m plus 1 duplexes. So this construction is the basis base, and let us revisit it. We can designate the members of D1 as duplexes and can have abbreviation for each member as dr, where r is 0 to m, and as such the cardinality of D1 is equal to m plus 1 greater than m equal to e over 2. Let me have a pause. We are approaching the conjecture every even number e greater than 2 to be written as a sum of a pair of primes. We are organizing E in such a way that we reach at a set D1, and this set is a setup of duplexes, DRs, and each DR, in fact, is a pair of numbers organization, interlinked pair of numbers, R from the upper layer and 2m minus R from the lower layer. D1, that way, is the largest possible set from which we have to sort out at least a single DR duplex such that both R and 2m minus R are primes to satisfy the conjecture. See, by this small step of construction of set D1 as set of duplexes, as elements DRs, as pairs R and 2m minus R, we have restated the proposition, and we have also very neatly, very cutely, very uniquely, very precisely mathematized the steps for reach at the proof of the conjecture. The requirement of the conjecture is that we shall sort out, we should single out, we shall point out, we shall specify, we classify, we pinpoint, we pick up one DR of the set D1 such that R and 2m minus R both are primes. Once we reach at this, once we are successful, once we can classify, once we can sort out, once we can signify, once we can tick mark a DR, a duplex, a member of D1, such that R and 2m minus R both are primes, then we will say that yes, we have satisfied the conjecture, and we will say yes, conjecture stands proved. But all what we have done up till this stage is simply we have organized a statement of the conjecture in another form. The statement of the conjecture is that every even number greater than 2 can be written as a sum of a pair of primes. But what we have done by this unique construction of the set D1 is that out of m plus 1 duplexes, DRs, at least one of it is a duplex where R and 2m minus R both are primes. So the statement of the conjecture that every even number greater than 2 can be written as a sum of a pair of primes in our context of the construction becomes that at least one of the duplex dr of set d1 is such that both R and 2m minus R are primes. It is this step, it is this way, it is this translation of the statement of the conjecture which deserves to be imbibed, comprehended, glimpsed, and inner structure is to be visited so that we can appreciate that our translation of the statement of the conjecture is mathematically satisfactorily, as that once the translation is mathematically exact, then and only then we will be in a position to say that yes, we are entering upon the proof of the conjecture. Every even number greater than 2 can be written as a sum of a pair of primes in our unique way of construction of the set D1 of duplexes of DRs R and 2m minus R amounts to that out of m plus 1 elements of the set D1, m plus 1 duplexes, and m plus 1 designated elements DRs, at least one of them is such that R and 2m minus R both are primes. The focus of this step is simply to have a translation of the statement of the conjecture. Conjecture statement as it is, as that even number can be written as a sum of a pair of primes in this reconstructed position is of a translation of this mathematical property as that one of the elements of D1, one of the duplexes, DR, is such that both R and 2m minus R are primes. Therefore, with this translation, we can now glimpse ahead, proceed ahead, as that now from set D1, we will further construct a subset D2 such that the elements DR are such that R is odd. In other way, R and 2m minus R both are odds. In other means that even duplexes are being ruled out. Means D1 is a set of m plus 1 duplexes where R is odd as well as even. But here from D1, we are reaching at a subset D2 only of the odd values of R. See, the set D1 is a set of m plus 1 duplexes. It is a set of m plus 1 elements. So the cardinality of the set D1 is m plus 1, while the cardinality of subset D2 will be only at least half of the cardinality of set D1. Now, see, symbolically, we are beginning with E is equal to m plus m. Therefore, m is E over 2, half of E. The cardinality of set D1 is equal to or more than E over 2 equal to m, because actually it is m plus 1, so it is equal to or greater than m. And the D2, from where the even numbers values of R and so of 2m minus R are standing ruled out. Therefore, the cardinality of the subset D2 is going to be E over 4. Once we are parallel with this approach, then we can glimpse and project as that if we proceed ahead and now reach at the subset of D2 itself, such that the composites of factors 3 stand ruled out, then we will be on a sequential path for ruling out all the composites. Let me now stop here. I am just up till this stage have been in a position to translate the statement of the conjecture even equal to P plus Q into specially constructed set of duplexes, and then the duplexes have been so approached that out of them the even value or duplexes are being segregated, and we are reaching at a subset D2. From here we will proceed ahead. Today, along with this much introductory statement, I am also uploading the complete steps slides. Same may be downloaded. One may go through them. One can coin their own queries and list their own learning steps needed to be clarified, and we will proceed ahead. We will continue with this. I hope that within a few steps, we will be in a position to have complete visit of the proof. Thank you very much.